Hello students, a very warm welcome to Magnetism lecture number 6 on 10 years PYQs, and we have completed 2020 JEE Mains PYQs and we are already on 2019 JEE Mains PYQs, and we are in fact today going to get into some of the most important concepts of your magnetism. They are very easy, but they are like the kind of the most frequently asked like model problems in your exam. So let's get into this topic. It's going to be super interesting. Not only that, do make sure that you're sharing this with your friends on your social media like WhatsApp groups, Telegram channels, Facebook groups, etc. Because you know what, it's a free of cost, high quality lecture. Unacademy, definitely do share it. And you are on JEE English, Unacademy, which is nothing but India's leading and largest JEE test preparation platform. That being said, students, I'm Muralidharan Krishna. I completed my MS in electrical engineering from one of the top ranking American university. I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. And I filed 25 patent applications in India and abroad. And that being said, if you're looking for a complete package for your JEE Mains and JEE Advanced preparation, it's going to be Unacademy subscription any day. Why do we say that? Because we have the best educators across the nation with whom you can attend daily live interactive classes on a very interesting platform with live polls and leaderboards, and that way your learning becomes very interesting and fun. And in fact, we have like authors of your popular JEE test preparation books like DC Pandey and DC Gupta on our platform, and you can also get access to lots and lots of test series set by the best educators, post which you will be also getting access to analysis. Using this analysis, you can improvise upon your overall performance. And students, one of the most important component of your JEE test preparation, that is live doubt clearing session, is also available on Unacademy subscription platform. So yes, it's overall a complete package for your JEE preparation. And not only that, every course on Unacademy subscription program is going to be well structured. You don't have to worry about the planning. We take care of the planning on our end. You will get access to doubt clearing session even in a very structured manner, so that you don't have any doubts in your mind. Like every fourth session is going to be a dedicated doubt clearing session, and you will also get access to lots of quizzes and mega quizzes. And moreover, on Unacademy subscription, there are no restrictions on your batches. You can attend as many classes as you want. And that being said, how do you avail Unacademy subscription? Do log in from your web-based version or your app. Then click on the left hand top corner extension bar, select plus, select IIT JEE as your goal, and hit on this get subscription button. Okay. And post this, you'll be redirected to the program selection page and the payment page, the ideal one for you. But let me tell you, students, if you are a 2021 aspirant, probably you may want to go for a 6-month program, which is going to cost you near about 25,250. And if you are a 2021 aspirant planning to drop, or you could be also like a 2021 aspirant who has completed 50% or 30% of the syllabus. Even if not, we have programs going on right now. Some of them are being hosted by vibrant educators, Bansal class educators on our platform. You can start attending them. Even for 2021 aspirants, we have many things going on. And how much is this 1-year program going to cost you? Less than 35,000. And if you are a 2023 aspirants, similarly, we have programs being hosted by the best educators of our platform. Not only that, some of the best coaching, like institutes of India are on our platform conducting classes every day. And if you're a 2023 aspirant, you may want to go for a 24-month program, because it's a 2-year long journey and you can give that kind of time. And yes, batches have only recently started, and the 24-month program is going to cost you like 50,400 for 2 years, like near about 25,000 a year, less than 70 rupees a day. So this is about a plus subscription. We have something beyond plus subscription known as iconic subscription. On iconic subscription, you can get one-on-one mentoring session, personal coaching from IIT and NIT alumni who are educators on our platform. So think about it, IIT and NIT alumni who have previously gone through this journey and have successfully cracked this journey. They know the ups and downs, and they can guide you with the motivations that you need. They know the strategies to successfully, complete your syllabus and, in a very systematic and strategical manner, and crack the exam successfully. So they can also give you those kind of strategies to prepare and crack your exam. And not only that, we have some of the best educators on the platform. You can also get personal advice from them. So if you can afford it, Iconic subscription can be one of the best things for your JEE preparation. And a 6-month Iconic subscription is going to cost you near about 35,000, less than 35,000, 34,200, and a 1-year subscription is going to cost you 58,500, and a 2-year subscription program is going to cost you 90,000 for 2 years, like 45,000 per year. And students, make sure you apply Murali Live code. If you don't see this pricing on your the subscription purchase, do apply Murali Live code so that you can get maximum discount. And not only that, you can unlock many features. It can be plus Iconic. You can apply Murali Live code even on combo subscription. Yes, we have recently introduced something known as combo subscription, where you can get a single economical pricing for your CBSE board coaching and IIT JEE board coaching with the best educators across the nation. And make sure you are applying Murali Live code so that you're able to get the best discount on them as well. And not only that, we have different combinations of combo subscription as well. You can go for a combo subscription where you have an Iconic and plus and a full Iconic as well. We'll discuss that at the end of the lecture. And do definitely apply Murali Live code to unlock any feature on your Unacademy subscription platform. So yes, students, let's get started with the problem. A very, very easy and an interesting problem. Okay, it's a very easy problem as well. So yeah, do have a look at this problem. Try to get started. We are getting into a different concept. This concept has been asked multiple times, so do focus on it. Okay. So particle having the same charge of an electron moves in a circular path. Okay, of radius how much? 0.5 centimeter under the influence of some given magnetic field 0.5 Tesla. Make sure everything is in SI units. If not, do correct it. If this is not in SI units, do convert it. If this is not in SI units, this is supposed to be in meters. Okay, you got that point. And it's not any type of mistake, but just I'm saying that you need to make sure you convert into SI units. One of the most important things when it comes to magnetism. As such, magnetism is where you spend time to solve the questions. If you have solved the question but with the wrong units, you're going to get the wrong answer. Make sure you're applying the units correctly. And then you have an electric field of 100 volt per meter to make it move in a straight path. So what is happening? Okay, forget the direction, etc. You know what you need to do. So it's a very if I'm going to go by formula, it's basically Fe is equal to Fp. Right, magnetic field is equal to force applied by magnetic field is equal to force applied by electric field. Nothing has been said exclusively about your directions, etc. So in such cases, you can directly write it down. Fe is equal to Fp. Okay, what is the force due to electric field? Q into electric field. Okay, in this case it's E into electric field, it is given to us. And what is due to the magnetic field? Q into V into B. Some velocity should be there, of course. Understood it? Correct? That's dependent upon velocity. Okay, but anyway, we know probably most of the things that we need to know. Why? We know that velocity is nothing but how much? Like electric field by magnetic field. Amazing. We have some of the best information that we need. Why? We pretty much found out everything. Why? Because we know what is the value of velocity. And what do we have? Radius of your that circular path. Okay, let's get into this question. Very easy question. Okay. Radius is going to be 0.5 centimeter. Let's write it down in terms of meters. That is actually the thing that we need to do if we want to get the answer correctly. Let me just once check it out. Yeah, of course, answers are given to confuse you in the manner, right? So be very careful. This should be 5 into 10 to the power minus 3 meters. Okay. What is the next thing that we need to do? Okay. We say that due to a magnetic field, it starts moving in a circle. In this case, it is not moving in a circle, right? But generally there would be a centripetal force associated with it due to the magnetic field. Okay. And that centripetal force magnitude is going to be the same as your magnetic fields. Okay. And what do we have? mv square by r is equal to qvb. And then we say one velocity or one speed goes off, and we have something like q into b divided by qbr divided by b is equal to m. Now, mass is equal to what do we have? QBR by V, and we know one more thing, right? V is equal to what? E by B. Let's substitute the value all at the end so that we don't make any mistake. Now let's start working around this problem. And mass is equal to Q into B into R divided by E by B. Hi Gagan, hi. Just noticed your this now. What do we have? Q B square by R into R divided by E. Is that it? Yes. Let's substitute the value. It has to be in SI units. That's the only thing that you need to take care of. Rest is all easy. The mass is equal to Q into B square into divided by E. Okay. Rest is easy, I believe. You know the concept. Now you don't need to do anything other than just substituting the value. Let's substitute the value and get the answer quickly. 1.6 into 10 to the power minus 19 coulombs. It's a very easy question, actually, trust me. Some approximations needs to be done, and we'll be doing that approximation on the way. Okay, B square is how much? Like 0.5 Tesla SI units. So half into half, however you would like to write it, 0.5 into 0.5. Then we are going to do that R was how much? 5 into 10 to the power minus 3. In fact, if you're noticing it, this could be like one of the easiest problems that you could have done in your exam, because the question is really easy. 100 volt per meter. Basically try to grasp the concept. You will get it very quickly, students. Yes. To the simplification part, it's going to be first of all 10 to the power, let me just cancel this and cancel this. It's going to be 10 to the power minus 5, 10 to the power minus 5, 10 to the power minus 24. We have the first thing that we need to know. And okay, 5 into 1.6, that's going to be 8. 8 into 1 by 2, 1 by 2, 1 by 4, 2. Simple. Mass is how much? Mass is going to be 2 into 10 to the power minus 24 kg. That's it. Simple. Very simple. Okay. So let's move on to the next problem then. Okay, now what do we have? We have an experiment here, and the electrons are accelerated from the rest by applying a voltage of 500 volts. Calculate the radius of the path where the magnetic field is millitesla. Okay. Given to you some values that you need to finally apply: mass of the electron, charge of the electron, etc. How do we do this? It's a very simple problem. Just think about it. Give it a moment. Okay, you can typically actually, one of the things you want to do is you want to generally do magnetism after electrostatics. If you're good with electrostatics, magnetism becomes really very easy. Okay, so that way this is a very easy problem. We know the applied voltage. Let's get into this problem. Very easy. See what is being done in this case. Some work is being done. Due to what? Due to your applied field, or in this case it's a constant potential difference. Okay. And how much that comes out to be? Let's keep it as Q into V. And this is giving you what? This should be giving you some kinetic energy. Somewhere this energy has to be like converted into, right? That is half of mv square. Okay, so what do we know? We know something like v square. This equation is going to be v square is equal to 2 into q into v. This is voltage v or potential v, whatever you would like to call this, divided by capital V divided by. Okay, now what do we have? So some potential has been applied, and due to that potential there is some velocity associated with it, and due to that velocity there is going to be some magnetic force as well. I think we might have to substitute the value and simplify it. It's all electron. Okay, so charge we know, mass we know, everything we know, and it's also given to us in the question. Let's get started, and finally we are going to do that same thing that we used to do earlier, like approximate things. 2 into charge is 1.6 into 10 to the power minus 19 coulombs. Okay, fine. It's 500 volts SI units. It's a very simple problem, students. Really very simple. So something, if you have noticed recently in your JEE mains etc., little calculation intensive, you need to make approximations or apply these shortcuts. Shortcuts can be like really simple shortcuts. Okay, sometimes into 500 and divided by what do we have? Something like the mass of the electron, 9.1. So let's keep it as 9. Okay, 9.1. Let's keep it as 9.1 for now. Later on we are going to say this is nothing but 9. Okay, so yes, and this comes out to be what? 10 to the power 12. Is that what we have? So it's going to be what? 10 to the power have a situation here where it's not okay. Let's do it then. It's an easy problem only, students. Yes, it's an easy problem. So see, 2 and 500, what it is, 10 to the power 3. Okay, this and this gets cancelled out. What do you get? 10 to the power 12 on the numerator. Is that it? Yes. And what else can we say? This is like, instead of writing it down as 10 to the power 15, I'm going to write it down as 10 to the power 14. Because 16 is very easy to deal with. We know what is this? 4 by 3. 9.1, just forget it. Moment of inertia, we have a question. Don't worry, Daniel. Okay. It's a very easy concept. Don't worry. Moment of inertia. Okay, moment of inertia. Okay, we'll be doing it in... we'll see. We'll take it up in after this PYQs of your gravitation or something. Okay, moment of inertia, we'll do it. Okay. I thought magnetic moment is what you're talking about. So if velocity square is 16 by 9 into 10 to the power, we'll do it, Daniel, don't worry. Okay. Velocity square is 16 by 9 into 10 to the power 14. Okay, definitely do this, students. Never ever miss out such things. Okay, don't, spend a lot of time, especially in your magnetism, around, beat any of them. Okay, beat any of the chapter. Don't spend a lot of time just trying to, oversimplify things or get a very accurate answer. There is no such accurate answer as it is. This is an approximate answer itself. 9.1, 1.6, they are themselves not an accurate, right? Accurate values. All right, now what do we have? 4 by 3. What is the next thing that we need? 4 by 3 into 10 to the power 7. Okay. What is the next thing that we need to do? We need to find out what is going to be the radius. We know the velocity. Simply set. Same thing. Lot of the questions have this thing. Centripetal force is balanced by, a magnetic force. That is when it can rotate this way. mv square into divided by radius of orbit is equal to q into v into b. Okay. Where you need to be very careful around. So what is radius of orbit is going to be mv by qb. Okay, easy. So far everything's easy. It's an easy question. Why so far and all? It's actually a very easy question if you're thinking about it that way. M into V divided by Q and B. Okay, this is kind of an expression that if you're solving too much, you would have started remembering them. Okay, now what do we have? Mass in kg. 9.1, not required actually. You can write it down as 9 in this case, but be careful whenever necessary. Sometimes it can be 17 on the denominator or 1.7 on the denominator. So yeah, whenever necessary, what do I mean by that. What about velocity? Velocity, we just calculated it. It's 4 by 3 into 10 to the power 7. Okay. Come on, guys. What is the next thing that we have? We need to divide it by the charge value. We'll be doing that as well. Q 1.6 into 10 to the power minus 19 into that of field. Field is given in millitesla. And what should we be doing? Multiplying it with 10 to the power minus 3. I guess now it's a very, very easy problem. 3 times. Okay. And you can take this to be 10 to the power minus 19, 10 to the power minus 19, 10 to the power, how much is this going to be? 10 to the power minus 12, and this is going to be like 10 to the minus 1. This is going to be 10 to the power minus 11. Okay. I'll take this value simply to be 3 into 0.4 divided by 1.6 into 10 to the power minus 11 to the minus. Okay, so you know how to do this question. Okay, I need not tell you anymore. So just cancel this, cancel this. You'll be having something like 4. This is going to be 0.75. Okay, into 10 to the power minus 11. That's it. End of this story. 0.75 into 10 to the power minus 11 meters. I think we don't have to revise these concepts again because probably we have discussed them already. So if you're noticing it, that's what I told you. Be very careful, be very careful, be very careful. Okay, have we made any mistake in this case? I think we made some mistake. Just a moment, students. Let me quickly have a look at it. 2qv divided by mass. Just everything is working. 10 to the power 12, 10 to the power 15. Yes, correct. Just a moment. Let's check it out. What's going wrong? 10 to the power 12, 10 to the power 3, yes, 10 to the power 3, 10 to the power 14, 10 to the power 14, okay, 4 by 3 into 10 to the power 7. Okay, that's fine. Then I think this is a very important problem. So questions, let's check it out. Okay, that way, let's go, and this is fine. This is a standard equation though, mv by qb. Okay, we forgot 10 to the power 7 in this case. That is where we made the mistake. Okay, this 10 to the power 7 has been missed out. So this would come out to be like 10 to the power minus 4. My mistake, 10 to the power minus 4. Literally my mistake. Apologies. And end of the story. Okay, that's it. Yes. So it should be in meters, 7 into 7.5 into 10 to the power minus 5 meters. Okay. I think we missed out to carry something. Make sure it does not happen while you do it. Yeah, there we go. Simple. Simple. It's actually a very simple problem that was due to a very small made during the. So yeah, we have a circular coil having n turns and radius r and carrying a current I. It is held in the XZ plane in a magnetic field Pi. The torque on the coil due to the magnetic field is going to be. Okay. Some 0 is also given. Obviously, most of you know that n should not come on the denominator because n turns, what is going to happen? More torque on it, right? Because it carries like more current, n times more current. So obviously these two are not the answer. It should be one among them. If you are just calculating the direction in your mind, its answer is yes, simple. One into 500 sums each and every sum. Yeah, that is like random sums if you can do it, Daniel, but there is an issue. You need to focus on the weightage that you have for your exam. You cannot be like, I'll do random sums. Maybe you're spending majority of the time, like kind of doing like spending majority of the time on things at the moment. If you're especially a 2021 aspirant, I guess Daniel, you are yeah, that was Chirag. Okay, so I don't know like which year aspirant you are. So this is what very important concept. Okay, We'll do it, don't worry. So yes, this is what x and z plane. So if this is lying in x and z plane, how is the area vector? 22, you're 2022 aspect. Yeah, you have the time, but still focus on your weightage. Yeah, we'll do lots of sums, don't worry. Okay, we'll do as many sums as possible. But even if you're a 2022 aspirant, I wouldn't say you have a lot of time. It appears as if you have a lot of time now, but you are also only having a year for your preparation. If you miss out this year, probably it's not a very good thing. So your area vector is going to be like along j cap, right? Given that current is in this direction, okay, j cap, assuming current is in like the anti-clockwise direction. Okay. I'm discussing this point because there have been questions asking you clockwise, anti-clockwise direction. So just do focus on direction. Another important thing about your magnetism is directions. Concepts, directions, numericals, approximation, units. Okay. If you have noticed the PYQ, this is the pattern. Okay. And how is the magnetic field applied? Magnetic field is applied in this direction, along the x-axis. Focus on this question because we are going to deal with a very similar question very soon. In that case, of course, it's going to be little twisted. What is twisted? This thing is going to be twisted. B of I cap. What should be your torque? It's perpendicular, right? What is this direction? Magnetic moment's direction. What is the value of magnetic moment in this case for this, coil having R radius and carrying current I in x z plane? It's going to be current into area into that of j cap, right? It's lying in x z plane. I'm being very specific about this thing because make sure you're not making any mistake. And n will be added here. Why? Because it carries n times more current due to n such like coils. So it should be n into I into pi into r square into that of j cap. Simply said, this should be it. Next. Next thing we know is very simple. It is torque. Torque is going to be magnetic moment vector M cross B. Okay, you very well now know that it is basically J cross I. It is supposed to be like minus K. Whatever it is, torque is going to be in the minus K direction, which also makes sense. Okay. In this case, what is the value of magnetic moment? N into I into, this rest is easy, pi into r square. If you understood the direction, that is where I wanted to spend a majority of this time so that you understand the direction J. And this is B of I cap. It's all given to you in the question. Okay. That's it. J into I minus K, right? I, J, K, you know the direction. It's N into I into B into that of pi r square or into that of minus K. Okay, we are missing out one thing, that is your vectorial notation on the top of your torque. Okay, end of the story. Okay, once you understood, it's not going to be, not going to be 0. You understood the value very well. You just draw it once. So magnitude of torque is going to be N into I into B into pi r square. That's it. Whatever, like, b into pi r square into I into. Okay, very simple problem. Let's get into the next problem. Yeah, it's like a minute problem if you understood. Not even a minute, 20 seconds problem if you understood that. Just draw the direction and conclude it if you're little not confident about it. But if it lies in XZ plane, it's going to be K cap. I cap, K cap, sorry, it lies in XZ plane, it's going to be J cap. If it's J cap, I cap, it's going to be K cap. So not in zero. Yes. Okay, let's get into the next problem. Yeah, that was a problem of your 2090 JEE mains. So definitely it's also an easy chapter if you are looking at it from that way. Some problems can be little time taking, and this is one such problem where it is going to be super easy. A proton and an alpha particle with their masses in the ratio of 1:4 and charges in the ratio of 1:2, okay, are accelerated from the rest through a potential difference of how much? V. Try it out, students. We have already done the problem to the most extent. Just try it out. Okay. If a uniform magnetic field B is set up perpendicular to both of the velocities of proton and alpha particle, the ratio of Rp is to R alpha. Here you need to just maintain the accuracy. That is the most important part. If you already understood the first question, okay, and attended the session from the beginning, this is a very simple problem. I didn't get your question. Okay, when to use perpendicular and parallel axis? Depends how it is, how you are rotating it, right? You're asking about your rotational motion, I guess. Yeah, Daniel will get into that concept. Let's not mix up the concept. Yeah, see, depending upon how you're applying your torque, etc., it depends totally how you're going to apply it. Are you going to rotate it along the plane or at the center of the plane, etc.? Okay, let's get into this. Good. Yeah, I'll do a thing. I'll take up a session on moment of inertia next week. Don't worry. Okay. Okay, now let's get started, students. What is that we know? Let's write it down first of all. Sometimes we'll have the best of the clarity in such kind of questions. I don't want to miss out even a single answer. Mass ratio 1:4. Obviously proton is not going to have is going to have one of the least masses, not the least, but one of the least in terms of alpha particle. Okay. And then charge ratio, we know Q of proton is to Q of alpha is how much? 1:2. Just for a clarity. Okay. Next thing. What do we know? We know work done for your alpha particle is giving you what? Q of alpha into that of electric field. I must say electric field by distance, but it is potential difference, right? How it can be electric field, it will be a force then, right? And that means we know the first thing that we need to know. Okay, this is how much kinetic energy of your alpha particle. How much is that going to be? Going to be something like half of m v alpha, m of alpha into v alpha whole square. Okay, we'll get kind of like an expression from here. Let's not write it down twice and substitute alpha and proton and get the answer. That's what I'm saying. Okay, so we know v of alpha is equal to 2 times Q of alpha into the potential, standard potential, divided by m of alpha root of it. Yeah, some questions, it always happens, right? Nothing is good question. Are the questions are going to be from moderate level or easy level? Totally depends. Last question, I would say, see, if you understood the concept, last question is like a 20 seconds question. You would have never ever got one such question in any other chapter. So that way it's like a super easy question. Okay. But at the same time, you will see questions which are going to be like, taking even sometimes 10 minutes and all. I don't think generally, calculation wise, other than that numerically intensive question, you generally have easy questions from your magnetism, not tough questions according to. Okay. So similarly, can we say something like this? V of your proton is going to be 2 into Q of your proton into that of potential difference divided by potential difference is the same. Yeah, it's generally easy question most of the time. Sometimes it's little lengthy. Okay, it can be a twisted question even in your gravitation. Okay, today we have solved a problem where sign was the issue, just the sign was the issue. Students might have got the answer, but they might have ultimately marked the wrong answer because they missed out a small concept. Okay, the negative sign, etc. Then everything goes wrong, and probably you're not getting the right answer. Let's move on and get started and get the answer. Okay, now we know this thing. This is for any such particle. Let's keep it as particle X and later on do it. We should have done this earlier as well. mv orbiting a velocity, or we can say mvx whole square divided by radius x is equal to what? Centrifugal force, which is equal to like F of B. You must be so much accustomed to this by now. mqx vx into B. Okay, both under standard field. I'm not sure, but generally I don't think it is true, at least as far as your JEE Advanced is concerned. I need to definitely have a look at your JEE Mains problems. Okay, so what do we have? We have something like Rx is equal to m into x into v into x divided by q into x into that of p. We have this. What we need to do? We have to take R alpha, R proton by R alpha. Yeah, be careful from this point as well. This is also generally I don't think from your fluids you get direct questions. I need to check out once. Let's have a look at it. Generally I do have a look at your JEE Advanced problems. Your time do spend around your fluid mechanics, else don't do that according to me, unless you're doing a one-shot lecture or something at this moment. If you're a 2021 aspirant, if you're a 2022 aspirant, it's a different thing for you. If you're 2023, you'll ample amount of time. Do spend as much time as you can. My mistake. Let's quickly get over this. Good, nothing please. Yeah, I'll get to your point. Let us complete this. Practice PYQs, you'll understand what it is all about. If you're noticing the PYQs, you'll understand definitely the trend over the time. Isn't it like we understood in magnetism from this 2 years and also from the previous years what I've seen? It's mostly about units, basic concepts, sometimes lengthy calculation. Lengthy calculation, sometimes you have that in the rest of the chapters as well. Generally perceived as a tough chapter, easy in your JEE Mains. Even in advanced. Okay. What do we have? We have something like Rp divided by R alpha is equal to Mp divided by M alpha. Let's keep it this way. Into that of Q alpha by Qp into that of Vp by V alpha. Of course, it's a very easy problem now. Most of you have already done it. If not, quickly try to get the answer. 2021 aspirant, just do some PYQs if possible. If you have any access to one-shot lecture, do attend them. Get over with it. Don't spend a lot of your time on, unless you have done it previously. Yes, it's worth it. Else, don't spend a lot of your time on your fluid mechanics, etc. students. Not at all worth your time. Trust me, going to consume so much time. So many concepts are there. Okay, you may get it from any of the concepts. It does not have so much weightage. Okay, so just focus on the things that have a lot of weightage. That is the best thing to do ever, you know. That is one of the mistakes every aspirant makes and later on realizes. It could be some of the teachers that are teaching you as well, you know. So that is the thing that everyone does. So that's why they keep telling you. Okay, and what do we have? Velocity to be 2q proton. Right? We are writing down the velocity of your proton. Okay. 2q velocity of proton divided by equal to half mv square. M of proton. That is on the numerator. And on the denominator, what do we have? 2q alpha into electric field divided by mass of alpha. This is where we are spending time. If you know, if you understood it, you should be very quick about it. If anything, it feels really confusing, right, students? You can do a thing. Now, why the eraser is not working? Just one student. Oh my goodness. There was some technical issues. Just a moment. Let me write it down quickly. What is happening? I hope that is not visible on the screen as well. Just something is going on. Okay. Yeah. Very good. Let's write it down on a separate page. Forget this for now. There are some technical issues. Okay, what do we have? Rp by R alpha is equal to, we have MP by M alpha and QP by MP by M alpha and QP by Q alpha. Let's quickly get over this. Okay. Not at all worth so much time. So Q alpha by QP. And what do we have as the second term? You know, it's going to be under root 2QP by into E divided by MP divided by that of under root of 2Q alpha into E divided by M of alpha. Okay, don't worry, whatever has been written in the last slide, that's due to some technical issues, just to avoid it. 2 gets cancelled out, E gets cancelled out, and what do we have finally? We have something like, this is 1 by, right? So this is going to be to the power half MP divided by M alpha. So if it's half in one place, even in the other place it's going to be half. Okay, and what do we have over here? Direct multiplication or indirect multiplication. Sorry, this is QP Q alpha. So this is again half. My mistake. Okay, so Q alpha divided by QP half. Okay, it's better to substitute it individually sometimes. This is little kind of, you know, a risky way and where you can make mistakes. Definitely, this is definitely something that I don't recommend you do it up until the last thing. You substitute it in between, you make lesser mistakes. Just verify if everything is going correct. In such questions, it becomes really very important. And we know a few things, right? Given to us mass ratio 1:4, we just wrote it. This is going to be like 1 by 4 to the power 1 by 2, and Q P by Q alpha is how much? 1:2. So Q alpha by QP is how much? 2 by 1. What do we have inside the roots? So we can just cancel it. So we will be having 1 by 2 root. Yes, this is what RP by RL. That's it. It could have been a lot easier, but I think this also was easy. Finally, even using the value, but I think lesser confusion. This confusions could have been avoided if you would have substituted earlier. Okay, so and I think there was something. That's why it feels that way as well, I guess. There you go. End of the story. Okay, let's get into the next question. So rather a very simple question. That was also a very simple question. Again, we have another easy question. Okay. So let's do a thing first of all. How to answer this question even without diving deep into the question. I'll explain you the concept. If you don't know that, I'll take you to each and everything. But just to focus on what we are going to do now. We don't want to get like deep into this question and see if we know the answer. Okay. This is in this direction. Outwards. Right? Let me indicate this with A. It's carrying current like this. This is my right hand, and at point P, how does it come? Outwards. Okay. Let's give it a dot. Very easy question. That's the reason I'm doing it. First of all, from the options itself, it's quite possible for many of the questions. Next, let's call this as B. Due to B, what is happening? It's inside. Good. So it should be, and in which direction it is? Both of them are inside and outside. That means it is either along Z or minus Z, right? It should have been somewhere like this. So in this case, this is not correct. This is not correct. Probably this is also not correct. Why? One is inside, one is outside. It should be 0. Just from symmetry point of view, you can directly answer this. To quickly remind you things, what is the direction is very important. Don't forget this thing. Direction is very important in magnetism. Okay, due to a rod, we say, okay, this is, if you understood it, good. And if you don't know this, yes, try to learn this here itself. Okay, we say it's mu naught into I divided by 4 pi into that of sine of theta 1 plus that of sine of theta 2. Let's do it specifically for this case. Okay, and divided by R. Okay, divided by D. That's my mistake. I just mu naught divided by 4 pi into I by D into sine theta 1 plus sine theta 2. Okay, now let's first of all think about this guy. Okay, magnitude is going to be the same, opposite directions. Really simple, 0. Okay, how do we do theta 1? Theta 1 in this case is how much? A very long straight wire. Theta 1 is 90 degrees. Theta 2 probably does not even exist. Okay, in this case probably theta 2 does not even exist. Even if it exists, it exists probably, right? Because this continuation shows you it exists. So 90 degrees, 90 degrees. Okay, if you're extending this is also 90 degrees, this is also 90 degrees. That's it. So sine 90, which is that alpha value is going to be this. Mistake. That's correct. Okay, it should be what? Mu naught into I by 4 pi into t into that of sine 90 plus of sine 90, basically 2. Just a moment. Point makes with this, may not confuse you. What do we have? 1 and 1, so the answer should be like mu naught be in this case due to this rod is, we just know due to the rod is mu naught I by 2 pi d. Okay, good, very good. Okay, now let's call this as something like B. For both it's the same. For both the extension has been given, etc, etc. This is just for a concept revision. Just try to grasp it quickly. Double advanced sum. What is double advanced sum, Daniel? Okay, this is A. Again, outside. At this point. Okay, then Let me call this as B. You'll be adding up both. What is double advanced thing, Daniel? B. Okay, or whatever you like to call this. This is going to be inside. Be sure about this. Very important. So net field is going to be BA plus of BB. Okay, let me write it down carefully so that you understand this point. BA is in which direction? Both are at a distance D, that's why it is possible. Okay, BA is at which direction? Inside. So we can outside. Yes, so we can say this is B into plus of K cap, and BB is in inside. End of the story. It's going to be into minus K cap, so this should be 0. Okay, that's it. Okay, at this point field should be 0. Okay, let's move on to the next problem. This is a real interesting. Up until now, if you understood directions, units, it was all easy. This is also quite easy. Again, it's again about direction. Okay, little bit about direction. It's a simple problem and also something to do with units as. Okay. A rectangular coil has some dimensions that is given to you, and it has 100 turns. It is carrying a current of 3 amperes in the clockwise direction. Okay, it's carrying in the clockwise direction. Good. And is kept at the origin, is kept centered at the origin XZ plane. A magnetic field of 1 Tesla is applied along x-axis. If the coil is tilted by 45 degrees about z-axis, then the torque on the coil is up. Try to understand the direction, that's it. It's tilted about which axis? Z-axis. Okay, let's understand this. Carefully, if you understand this point, it's quite easy. Okay, do a thing. Let's draw the axis and understand it. First of all, we have something like x and z plane, and then we again have, okay, I'm just drawing this axis for the convenience. Okay, and this is x and z. So try to understand this concept. Later on we can apply the equation, formula, etc. It is initially on the x z plane, okay, carrying current in the clockwise direction. Okay, does not matter so much clockwise, anti-clockwise, to just calculate the magnitude. And now, what is the direction of your magnetic moment? It's going to be perpendicular to the area, right? It's going to be like okay. So how is it? It should be outside, right? Outside the loop in this direction. Okay, yes. Inside or outside? Inside. It should be inside. It's a mistake. Let me just quickly correct this. It should be inside. It does not matter so much anyway, but let's correct it. Be like this. Okay. Now, the moment's direction. and this is what some y-axis, negative y-axis. How is your applied field 1 Tesla along x-axis? This was how much initially? 90 degrees. Now what have we done? We said that you know what, we are going to rotate this coil. How? About z-axis. How many degrees? 45 degrees. Like this. What happens to moment? Moment also rotates 45 degrees. Okay, and that would be like. So what happens to your final moment if you're thinking about it? It's going to be like, you know, along this way, some still in the y plane, but now your field and your moment is at an angle like how much? 135 degrees. Okay, that's it. You understood this point. Really simple. Field is like this. Yeah, or it could be also this direction, but does not matter. This angle is how much? Initially this was like 90 degrees. Now it's no more 90 degrees. It's 135 degrees. Is that it? Okay, we know this thing. Okay, we are not going to draw the loop again. What is torque? Torque on the coil now is going to be like M cross P. So it should be MB sine 135 degrees, right? Is that it? The other way around, but into some, you know, it's going to be like in this direction. We are not worried about it. We are just talking about, you know, magnitude. We are just considering magnitude. Write it down as MB sine of 45. Okay, end of the story. You need to calculate M. What is the magnetic moment of this coil? Magnetic moment of this coil is going to be current 3 ampere I into area. Okay, and in this case this is going to be 3 into area. Let's do it on the next page. I guess it's a very easy problem, but we don't want to make any mistake in this case. Move on to the next page. M is equal to I into that of A, which is going to be I into A into B. That is going to be 3 amperes into that of 5 centimeters into 2.5 centimeters. 5 centimeters, that is 10 to the power minus 2 meter, into 2.5 centimeters. Again 10 to the power minus 2. This comes out to be how much? Like 7.5 into 5. Let's keep it as it is. I don't know, like this is like a super complicated calculation. Okay, so it should be like I think a lot of calculation is there in this case, apart from units, etc. So anyway, 15 into 2.5 is going to be how much? 37.5. into 10 to the power minus 4. Okay, ampere, meter square, etc. If you want to write it down, you can write it down, because we are dealing with units. So we got magnetic moment. Let me just re-verify that. The moment 13. Right. Just a confusing problem as such. Okay, torque is going to be M B sine 45 degrees. Let's take it up on the next page. That's it. We know all the values that we need. It's all in SI units. Okay. Anyway. Okay. MB sine 45 degrees. And magnetic moment, we just calculated it. It's 37.5 into that of 10 to the power minus 4 into that of 1 Tesla field into that of 1 by root 2. Okay, sine 45 degrees. Okay, this is like 1.414. Little, like calculation oriented question. Definitely you can take this to be approximately 1.5 and conclude the answer in your exam and see which is the nearest option. Of course, that is something that you need to do, but according to me, what this would come out to be, 1.414 is there. We will do the calculation a little bit. This is like going to be 2. Okay, then we have 8.5 times or 5 times, or like going to 6 times something. But okay, it's 26 basically. You can add a 10 to the power 1. 2.6 into 10 to the power minus 3 Newton meter. Is that it? No, let's check it out. 0.27. Okay, Newton meter. That's going wrong. Okay, 100 turns. Okay, we forgot the fact that it has 100 turns. So now torque is going to be 100 times this. Okay. This is torque due to 1 turn, right? And due to 100 turns, it is going to be 100 times. Total is going to be 100 times tau. 100 times tau is going to be 0.26, approximately 0.26 Newton meter. Little complicated calculation. We even have to kind of miss out some easy calculations in these kind of questions. Definitely, takes a lot of time. Okay, it took a lot of time. Alright, let's get into the next one. Now we have a really interesting question. I believe that was little time taking. Returns. It's going to be n times tau. Let's get into the next question. Okay, now this is a very simple question. A rigid square loop of side A carrying current I2. So here it is carrying a current I2. Okay, is lying on the horizontal surface near a long wire carrying a current I1. Okay, in the same plane. Okay, they both are in the same plane. Now the question arises whether this is going to be attractive, repulsive, or attractive. First, let's see whether we are able to get the answer even without getting too much into the question. Okay, we are going to do F is equal to B I into L cross B. Okay, so in that case, I'll get into the detail of the question. So one way to think about it is, this is going to create the field. Okay, this is going to create the field. That means no effect or no force on these sides. Which side? On this side and this side. Okay, only this on this side remains. If you are thinking about it, even directionally, if you are thinking about it, this is how the field is going to be. Inside field, then what do we have? We have current in this direction. For this guy, I am specifically discussing this one. Calling here field to be some B1, because it's dependent upon distance. Okay, so your current is in this direction, field is inside. That means it's a repulsive force. Okay, if at all only repulsive, zero, attractive has been given to you. To an extent, you can even answer this question quite easily. Little confusing options have been given. Okay, current is flowing like this and field is inside. So this is going to be a repulsive force. The way to think about it is, if you want to remember, what is the direction of flow of current? One is like this, one is like this. That means they are going to repel. Okay. And you very well know, if this was repulsive, this is supposed to be attractive. Field does not change. This is going to be attractive, but you also know the magnitude of B1 is supposed to be greater than the magnitude of B2. That means it is going to be overall repulsive. This is wrong. This is wrong. Of course, from the numbers as well, you can see. Okay, this is how much distance? A. If you remember, it's going to be mu naught by 4 pi divided by D. Into I divided by D into sine theta 1 plus of sine theta 2. Okay, and this is, and as you can see in this case, how is it acting? It's acting as if it's an infinitely long wire, sine 90 degrees, sine 90 degrees. So on the numerator you'll be having a 2 pi on one side, on the other side you'll be having a 4 pi. So 4 pi 2 pi minus on the denominator, you're going to get again 4 pi. Let's get into the question. It's a very simple question. So first of all, let's say here you need to find out the field. It's like B1. Okay, field is always going to be inside. Let's define some axes. So let's keep this as x-axis. One should be good enough to understand the direction of the force. And we are going to say, what is the value of field due to this rod, infinitely long rod? This is going to be B1. Let's keep it as mu naught by 4 pi into that of I1 or I2? I1, right? I1 into that of like divided by distance into that of sine of theta 1 90 degrees plus of sine of theta 2 again 90 degrees. Okay, that means what is the value of B1? Value of B1 is going to be mu naught by 2 pi into I1 divided by A. Okay, this is the field value. Okay, now we just analyzed it. We can analyze it again. What is the force? Force is going to be I into I, in this case is due to ohm. This I to I, actually to be more accurate, this I to I, this and this does not experience any force. It's along the axis. I2 into that of B1 into that of L. What is this L? Length of this this current carrying wire with current I2 in it. Okay. And coming to the direction, what is supposed to be the direction? See, again, let's do it this way. Your current is carrying, like, right, I2 is in this direction, Field is in which way? Field is like this, so it's supposed to be repulsive. Repulsive. So we can say it's X cap. Okay, done. That's it. Understood this point? There is nothing more to explain in this. You very well understood the next thing as well. There is a small thing that you need to care about. Mu naught by 2 pi into I2 into I1. It could have been I1 into I2, but anyway, divided by A into that of X cap. Okay, little bit more simplification is left, and mu naught by 2 pi into I1 into that of I2 into that of X cap. Let's keep it as it is. Okay, second one I need not explain you so much. You would have got already the kind of thing that you need to know. It's going to be inside. Okay, that means let's call this as B2 or B1 dash. This is going to be what? B1 dash. So B1 dash value is how much? Mu naught by 4 pi. Everything continues as it is. I1 divided by distance, like D dash, into that of sine of 90 degrees plus of sine of 90 degrees. Okay. How much is the distance? Distance is A plus of A going to be 2A. That's it. Okay, it's mu naught by 4 pi into that of I1 divided by 2A into that of 2, right? This is nothing but 2. So we would be having something like mu naught by 4 pi into I1 by A. Okay. If we took this as F, we'll take an F dash, and value of F dash is how much? Simply said, F dash's value, very easy, it's going to be like I into L into B. That is all fine. That means it is mu naught into 4 pi, sorry, divided by 4 pi into I1 into I2 divided by A into that of an A. Why into that of an A? Length A. Let me remind you that. Okay, ILB, that is what we have done, or LIB, whatever like you would like to call it, BIL, however you would like to remember this. But what is the most important thing that we need to understand? Whether it's repulsive or attractive. This is X direction. Again, current in this direction, of course, two same side, like same direction current, it's going to be attractive force. You can understand it that way. This is the way current is flowing, field is going to be inside, okay, and this is the way this current is flowing and field is inside. That means your force has to be attractive. End of the story. Understood it? Good. If not, try to understand it. Minus X cap. It does not matter so much, but yeah, let's keep it this way. So mu naught by 4 pi into I1, I2 into that of X cap. We have F dash and we have F. Okay. That means what is the net force on this, like loop F plus of F dash. Okay. That's it. So net force is supposed to be F plus of F dash. Okay, we'll take care of the sign later. Keep it as x cap outside. What did we have? Mu naught by 2 pi into that of I1 I2 minus of mu naught by 4 pi. You very well know what is the answer now. It's a very quiet and easy. Even earlier it was an easy problem. It's all about direction. Okay, that's it. Simply said, net force is how much? It's going to be mu naught by 4 pi into that of I1 into I2 that of x cap. End of the story, students. Okay, direction was the key thing. That's it. Direction and understanding. Force is equal to what? I into L cross B. Same direction, attractive, opposite direction, repulsive. Okay, let's get into the next question. Hi Varun, I hope you are getting this chapter. It's quite an easy chapter where we are spending majority of the time with your direction and concepts. But otherwise, it's a very, very easy chapter. If you noticed all the problems so far, they were like damn easy. Hi Varun, hi. What do we have here? We have an moving coil galvanometer, little bit of your electrical instrumentation question. Very easy question, but be careful about the units again. That's 175 turns, area 1 centimeter square, and torsion constant of how much? Like 10 to the power minus 6 Newton meter per radians, which is totally fine. Okay. Now, okay, very careful about the units in this question. That's it. But don't worry, try to complete all the PYQs. Your gravitation will be complete. Don't worry about it. Okay. If you think the lecture is slow, you can fast forward it, but do not fast forward during the concept phase. Or if you think you know how to do the calculation, still do not fast forward it during the concept phase. Very important, because magnetism, it's about mostly direction concepts. Okay, for a current of 1 milliampere. What is the value of field approximately? Okay, let's get into this. This is a very, very, very simple problem. Okay, again, I'm saying that it's a very simple problem because you will understand it. It's a very simple problem. It's an electrical instrumentation question, guys. That's torque is equal to K into theta. Okay, what is this K? K is not that spring constant K. This is the torsion constant K. Is equal to how much? N times current into A into B. Basically, moment cross B. Okay, if you haven't understood that concept yet, this is the place to understand this. Okay, that's what we need to do. End of the story. Okay, but one thing, just be careful. Let me write it down. First of all, whatever we have in SI units, I'm not going to write it down. Whatever we don't have in SI units, I'm going to write it down. What is that we don't have in SI units? Area, which is like 1 centimeter square. If I'm going to express it in meter square, it should be 10 to the power minus 4 meter square. Okay. Other than that, do we have something that's not in SI units? That's going to be 1 milliampere. 1 milliampere is how much? 1 milliampere is like 10 to the power minus 3 ampere. Okay, so far everything is done. Torsion constant is nothing but just like your spring constant, but for a rotational motion. Okay, in rotational motion you have theta angle deflection, right? It's not like dx, it's like d theta or theta. Then what happens is this tries to pull back with an torque k into theta. There it was k into x, force is equal to k into x. Here it's k into theta. That's the only difference one. Yes, kx, force is equal to k into x. Here it is k into theta. Okay, try to kind of correlate things with your rotational part. For an example, we did a problem on SHM, which was from a magnetism. There we had to take we had to find out like time period, I guess. So if you remember what we used to say there, we found a relationship between acceleration and x. Here we'll find a relationship between acceleration and theta, and similarly do the same thing and say that that factor is proportional to omega square. Similarly, in this case as well, it's k into theta. That's it. Okay. Very, very easy, guys. Very easy, but there is a little twist. Let me write it down. Okay, what is the value of theta given to you in degrees, right? And what is the value of torsion constant given to you per radians? Convert this into radians. End of the story. Now rest basically what we are going to do, k into theta, that I'm going to write down over here. What are we getting? K is 10 to the power minus 6. This is SI units, radians, into pi by 180 is equal to how much? Is equal to NIAB. Again, everything in SI units. Okay, very, very important thing. N is how much? 175 turns. 175 times more current would be kind of appearing. And what is the value of current? We know current value is 10 to the power minus 3 ampere. And then what is the value of area? 10 to the power minus 4 meter square. Okay. It's a quite an easy problem, and we need to find out that B. Okay. Finally, we need to do some approximation. Again, no calculator. Again, same old thing. Okay, again we need to do that. Wow, no, this is a headache. Of course, there's a little bit of an headache involved in this problem. Okay, so we have 10 to the power minus 3, 10 to the power minus 1 in this case. So let's do the approximation and conclude the calculation as quickly as possible. Okay, so we have B is equal to, okay, every time we are adapting some new kind of technique to solve the problem as quickly as possible, and here also we'll be doing something like that. Okay, 180 into 175, trust me, it's going to take a lot of time if you're going to do it step by step. Like, I mean, like, not even step by step if you're going to calculate it accurately. So what I'm saying is, just focus on this thing as well. This is what, approximately like 3.14. So approximately considered to be this to be like 3. Okay, little more than 3. So this also should be little less than 60. How much is 60 into 175? Okay, 600 into 75 plus of 75 into 6. So that comes down to something like 350, 600. Just let me again do that thing. Okay, 150 into 3. So that is 450. Okay, 600 plus 75 into 6. 75 into 6 is how much? 75 into 6 is like 150 times 3. That is 450. 450. So that is going to be approximately something like 1 divided by 10,500. It's not 10,500. Probably it is something like, just take it as, 10,000 itself. So how much are we getting this? Like 10 to the power minus 4 into 10 to the power minus 1. So what should be the value? Value should be 10 to somewhere near about 1 into 10 to the power minus 5 Tesla. Sometimes it can be numerical type questions, that is where problem will arise, but I don't think this kind of calculations will be asked in numerical based question. Okay, just going wrong, doing some mistake in this case, because there appears to be some mistake in terms. Yeah, 10,700, that is all fine. Okay, 1,700, right? It's no. 10,000, yeah. And we already have a 10 to the power minus 1 on the denominator side. Okay, so this should be like 10 to the power plus 1. My mistake. This is plus 1. Okay. Where have I done the mistake? Let me explain you. Very careful around this kind of problems. So this was 10 to the power minus 1 over here. Once carried on the denominator, it becomes 10 to the power plus 1. Just to correct this point, and you'll be getting this as 10 to the power minus 3. Okay, be careful, and yeah, because your answers are like 10 to the power minus 5, I would have marked it as 10 to the power minus 5. Luckily there was no 10 to the power minus 5, but yes, make sure you are doing the correct thing. Approximately 10 to the power minus 3 Tesla. Okay, yeah, very important concept, electrical measuring instruments, and we have already covered it in a special class, a full-fledged complete lecture, full-length high quality lecture for free of cost on your Unacademy learning app. So try to complete this lecture, and it's only 4 hours, and we have completed every such model problem. This includes, you know, whatever we have discussed here, and as well as like the NIAB concept, etc., torque on the moving coil, galvanometer, and how to convert galvanometer into ammeter and voltmeter, what is the difference between ideal voltmeter and your practical voltmeters, and as well as your ammeters, and what is meter bridge, end correction in meter bridge, and also some error analysis based problems, etc., like JEE advanced level, JEE mains level problem. Everything is available for free of cost on your Unacademy learning app, and more importantly in a single shot, that too in 4 hours. One of the most important chapters for your JEE preparation, all it would take is 4 hours, and you will be able to score at least 1 question. Typically you may get 1 question or even more, 3 questions from your current electricity. So this is a free of cost special class. Yeah, we'll do that. We'll start with semiconductors soon. Yeah, we'll do that. Don't worry about it. So you're a 2021 aspirant, Varun. So yes, it's only 4 hours, simple class, and yeah, 4 hours, 1 session, one question, lot of weightage, you know, that way. That is like a very short chapter. Yeah, we'll do that, Varun. Don't worry about it. Next week or post that week, we'll get started. You're 2021 or 2022 aspirant, and 2021 aspirant. Okay, we'll do that next week probably. Okay, and students, do download Telegram app if you don't have one, and why? Click on this link that is available in the description box below, so that you can get onto a Telegram channel and get live before time updates on every class conducted by a JEE English team, be it on you know, like Unacademy learning app or YouTube channel. So yeah, definitely do click onto that link. And that being said, if you're looking for a complete package for your JEE Mains and JEE Advanced preparation, it's going to be an Unacademy subscription any day. Why do we say that? Because we have the best educators across the nation with whom you can attend daily live interactive classes on a very interesting platform with live polls and leaderboards. Not only that, we have you know, authors of your books like DC Pandey and DC Gupta sir on our platform, and you can also attend lots of test series set by the best educators across the nation, post which you will not only just attend the test series, you'll also get analysis using which you can improve upon your overall performance. And students, you will also get access to one of the most important components of your JEE preparation, that is live doubt clearing sessions on an Unacademy subscription platform. So yes, students, you know what, you can attend all these programs in a very structured manner on an Unacademy subscription platform, and we take it in a systematic and a structured way, with you know, 4th session being the live doubt clearing session, and quizzes and mega quizzes with each and every course, and you know, like on an Unacademy subscription platform. And moreover, we do not have any batch restrictions on an Unacademy subscription platform, and you can, you know, like enroll to as many courses as you want. So that's you know, like a complete package for your JEE preparation. And students, like if you are a 2021 aspirant, you will go for a 6-month program which is going to cost you near about 25,000. Current in one class is totally not possible, Varun. So what we are doing right now is discussing PYQs, right? Go through the PYQs. So I think 4 sessions has been already completed on your Unacademy learning app. So students, current electricity all one shot, it does not make totally any sense, because it's a pretty lengthy chapter and a very important chapter. You cannot miss out on a single concept. Let's do something like that, you know, I pick up some of the important concepts and we can do it next week, something like that, you know, like in one shot. But still that does not cover for anything that you need for your exam. Better off like, you know, attend the PYQ sessions that I've conducted on Unacademy learning app. I'm discussing concept with each and everything. Still, I don't think like all of them have been covered. So you need to complete initial lectures that are available on A to Z lectures of current electricity. So that is also available on your Unacademy learning app, or you can attend it on JEE English channel. And first few lectures, because that is the only concept that I think that have not been asked but still can be asked. Other than that, attend the PYQs. Pretty much I think every concept has been covered. An electrical measuring instrument, we will do something like a one shot. I believe we'll do that next week. Okay, next to next week, whatever, like, I think current electricity is more important topic. We'll take it up early. Okay, that being said, a 12-month program is going to cost you less than 35,000. This is for 2021 aspirants who are planning to take a drop, or 2022 aspirants. And 2023 aspirants go for a 2-year program, because it's a 2-year long journey, and it's also going to cost you less than 70 rupees a day. 50,400 for 2 years, less than, like, near about 25,000 per year. Okay, you're absolutely welcome, Varun. And that being said, students, yes, you can also go for an iconic subscription where you can get one-on-one mentoring session, and personal advisors from IIT and NIT educators, NIT alumni who are educators on our platform. So they have previously gone through this journey and they have cracked this exam successfully. So they will be giving you the motivational sessions to keep you running. And not only that, they will be also providing you the strategies that can help you prepare efficiently for your exam, and as well as help you attend the exam very efficiently. If you can afford it, it's going to be one of the best things. And a 6-month program is going to cost you less than 35,000. A 1-year program is going to cost you 58,500, and the 2-year program is going to cost you 90,000 for 2 years, which comes down to 45k per year. And make sure you apply Murli live code, be it you go for plus, iconic, or even a combo subscription, so that you get maximum discount. Yes, we have recently introduced something known as a combo subscription, where you can get your coaching for both your IIT JEE and CBSE board preparation at an economical cost. It's going to be more economical than availing individual programs at one place with the best educators across the nation. Even on combo subscriptions, we have different combinations of this combo subscription. You can go for iconic plus, iconic. You can also go for plus and plus, and you can go for plus and iconic. And this starts at 3,037 per month if you go for a combo subscription. And that being said, you can take your JEE preparation to the next level with our personal coaching. We will conduct workshops, give you expert guidelines, and many more things. You can prepare with our team. We have a team of IITians and NITians and head of coaching institutes on JEE English. And students, do not forget to like this video, share this video. Do definitely share it on your social media platforms like WhatsApp groups, Telegram channels, and Facebook groups, etc. And yes, definitely do like this video as well, and click on that subscribe button and bell notification to get timely updates. And work hard and smart to achieve your success. We might be soon concluding your gravitation PYQs, so make sure you are covering gravitation as well. Okay, gravitation PYQs on your YouTube, of course. We will soon get started with a quick crash course on your gravitation or something. So yes, make sure you're attending it on tomorrow at 6 p.m. And students, do not forget to apply Murli live code whenever and wherever necessary, so that you can get the maximum discount on your subscription purchase, or avail maximum benefit. You can unlock many features. Yes, students, take care, stay safe, bye bye, see you tomorrow at